How's it going, everybody? Mr. Dickin here. This is going to be the very first video lesson that we have for this unit. You all have access to our Unit 1 target sheet. So this is broken down by the different concepts we'll be covering in Unit 1. I posted this online. I would strongly advise printing this thing out, especially because we have graphs involved. If you don't have a printer, that's fine too. You just kind of have to sketch your own graphs out. But the whole concept here, the whole idea is we want to make sure that you guys have a framework for what you're expected to know, right? So what types of problems might show up on a college placement test. So that's how we have these things broken down. Each video here should be relatively short. My goal is to not exceed 10 minutes for any one of them, simply because we're not doing a whole lot of problems for each video. So this video, we're only going to talk about target 1, and that's going to be solving linear equations. Following videos, we'll get into targets 2, 3, 4, blah, 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 blah. All right, so let's get going. If you don't have this printed out and you're working on a sheet of notebook paper, feel free to pause the video here so that way you have a chance to write this thing down. All right, when we are solving equations, our goal is to get x equals some number, right? Now, when we do that, we have to focus on one half of the equation at a time. So I'm not even going to worry about this stuff over here. I'm only focusing my attention on 5x plus 3, 5 times the quantity x plus 3. So I'm going to distribute that in. The 5 will go into the parentheses there. And that's going to give me 5x plus 15. Now, if I can, I'm going to simplify this left-hand side. Maybe there's like terms I can combine. And in this case, no, there's not. So I'll continue on. So now let's go to the other side. Let's see, 29 plus 7x. I can't really do anything there, so it's already as simplified as it can be. All right. So now we have this line of work. My goal is to get x's on one side and then plain old numbers, constants, to the other. Well, for this one, I prefer to have x's on the left. I always like to have x equals something. So I'm going to move anything with an x value, so like this 7x, I'm going to move that over to the left-hand side. When I do that, I would have a negative 2x as the result. On the left and on the right-hand side, those would knock each other out. Now, if my x's are on the left side, I want the plain old numbers on the right side. I want them on the other side of the equal sign. So I need to get rid of that 15, but whatever I do to one side, I have to do to the other. 29 minus 15, that's going to give me 14. So what I've done now is I've simplified things out. I have x's on one side of the equation. Now right here, I need to get rid of this coefficient of a negative 2. This is negative 2 times x. Well, to negate my multiplication, I'll need to divide that out. Whatever I do to one side of an equal sign, I have to do to everything on the other side. So I'll get x equals negative 7. Not too shabby. So that's just some straight up Algebra 1 style content. The next problem is going to be a little bit more challenging. And the reason I say that is because now we have fractions involved, and anytime people see fractions, they typically panic a bit. Not only do we have fractions, we also have a crap ton of negative signs. Woof. No bueno. All right, so here's how we're going to do this. First and foremost, I'm going to suggest that you rewrite these so that any negative sign is moved to the numerator. All right, so instead of negative 6/7, I'll put a negative 6 all over 7. And then right here I'll have plus a negative 2 over 5, and that has the variable of x. I like to put the variables in the numerator. It doesn't matter if it's in the numerator or directly next to it. Either one is fine. They mean the exact same thing. And that equals negative 1/2. Okay. So if we have a comfort level with fractions, we could absolutely just say, hey, let's add 6/7 to the other side and move from there. That's totally legal. We could do that. The problem, though, is some of us might not have that comfort level with fractions. And there might be, kind of different ways to settle this thing out. So here's what I'm going to suggest. And this is a process called clearing fractions. All right, so what we're going to do is we're going to figure out what is the common denominator if I looked at 7, 5, and 2. What numbers does 7, 5, and 2 all go into? Well, if you're ever stuck, it might not be the lowest one, but you could just multiply them straight together. So 7 times 5 times 2. I know 5 times 2 is 10, so times 7 would be 70. What I could do is I could multiply every single one of these fractions by 70, and what's going to happen is all of my denominators are going to go away because those denominators will somehow cancel out with the 70. So if I multiplied this first one by 70, well, 70 over 7, that reduces down to 10. So I have 10 times negative 6. If I multiply the second fraction by 70, 70 and 5, well, that reduces down to 14. And we had 14 times negative 2x. And then lastly, if I multiplied 70 times a negative 1 all over 2, 70 and 2, that reduces down to be 35 times negative 1. You'll notice now I have no denominators, aka no fractions. So let's solve. I have negative 60 plus negative 28x, so technically a minus 28x, equals negative 35. To solve from here, I need to add 60 to the other side. I'm getting negative 28x equals, let's see, negative 35 plus 60. That's the same as 60 minus 35, so that'd be 25. Then x equals 25 divided by 28, but the 28 was negative, so I'll throw the negative out front. So we get a fraction as an answer. Now, if we did it the original way, we'd still get the same answer, but you might have to deal with gross fractions along the way. All right, last problem. This one's going to be very similar to the first one. We need to make the left and right side as pretty as possible. Again, if you need to pause to write this down, please pause and write this down. And then we're going to move x's to one side, plain old numbers to the other. So if I distribute the negative 4 in there, I've got negative 4x minus 4 plus 6. 6x. Then if I go to simplify that, I'm noticing, hey, we've got negative 4x and a 6x. That combines to be a 2x. So 2x minus 4 is what's on the left-hand side. Over on the right, I'll distribute into parentheses. I've got 2x plus 4 minus 8. I've got some like terms here with the constant values of 4 and negative 8. So those simplify to 2x and then a negative 4. Well, now you might notice that the left-hand side is identical to the right-hand side. So if I tried adding 4 to the other side, the 4s would just cancel each other out. They'd disappear. Or if I tried taking away 2x to move that over, doesn't matter from which side to where, it's going to nullify. So what that means is since the left side and right side are identical, we have infinitely many solutions. No matter what I plug in for x, it would still work. The left side would balance out to the right side. Now, a lot of people get infinitely many and no solutions confused. And the way we would determine that is if the variable terms, in this case 2x's, matched, but the constants did not. So let's say we got rid of the 4 and made that, I don't know, a 7. Just playing a little what if. So here the variables would knock each other out, but the numbers clearly are not the same. They don't match. In this case, you would have no solution. All right, that's it. That's all, folks. If anything does not make sense, please let me know. Shoot me an email or talk to me in class. And as always, good luck, have fun, be safe, roll tide.